It is essential to know how our brain responds to the stimuli which trigger an anxiety response, so that you are equipped to deal appropriately with anxiety. Let me highlight the key areas of your brain that are involved, and then I will explain what happens inside the brain. The thalamus is the central hub for sights and sounds. The thalamus breaks down incoming visual cues by size, shape and colour, and auditory cues by volume and dissonance, and then signals the cortex. The cortex then gives raw sights and sounds meaning, enabling you to be conscious of what you are seeing and hearing. And I'll mention here that the prefrontal cortex is vital to turning off the anxiety response once the threat has passed. The amygdala is the emotional core of the brain, whose primary role is to trigger the fear response. Information passing through the amygdala is associated with an emotional significance. The bed nucleus of the stria terminals is particularly interesting when we discuss anxiety. While the amygdala sets off an immediate burst of fear, the BNST perpetuates the fear response, causing longer-term unease typical of anxiety. The locus coeruleus receives signals from the amygdala and initiates the classic anxiety response: rapid heartbeat, increased blood pressure, sweating, and pupil dilation. The hippocampus is your memory center, storing raw information from the senses, along with emotional baggage attached to the data by the amygdala. Now we know these key parts, what happens when we are anxious, stressed, or fearful? Anxiety, stress, and of course fear are triggered primarily through your senses. Sight and sound are first processed by the thalamus, filtering incoming cues and sent directly to the amygdala or to the cortex. Smell and touch go directly to the amygdala, bypassing the thalamus altogether. This is why smells often evoke very powerful memories or feelings. Any cues from your incoming senses that are associated with a threat in the amygdala, whether that threat is real or not, current or not, are immediately processed to trigger the fear response. This is the expressway. It happens before you consciously feel the fear. The hypothalamus and pituitary gland cause the adrenal glands to pump out high levels of the stress hormone cortisol. Too much cortisol short-circuits the cells of the hippocampus, making it difficult to organize the memory of a trauma or a stressful experience. Memories lose context and become fragmented. The body's sympathetic nervous system shifts into overdrive, causing the heart to beat faster, blood pressure to rise, and lungs to hyperventilate. Perspiration increases, and the skin's nerve endings tingle, causing goosebumps. Your senses become hyper-alert, freezing you momentarily as you drink in every detail. Adrenaline floods to the muscles, preparing you to fight or run away. The brain shifts focus from digestion to focus on the potential dangers, sometimes causing evacuation of the digestive tract through urination, defecation, or vomiting. Heck, if you're about to be eaten as someone else's dinner, why bother digesting your own? Only after the fear response has been activated does the conscious mind kick in. Some sensory information takes a more thoughtful route from the thalamus to the cortex. The cortex decides whether the sensory information warrants a fear response. If the fear is a genuine threat in space and time, the cortex signals the amygdala to continue being on alert. Fear is a good, useful response essential to survival. However, anxiety is a fear of something that cannot be located in space and time. Most often, it is that indefinable something triggered initially by something real that you sense, but that in itself is not threatening, but it is associated with a fearful memory. And the bed nucleus of the stria terminals perpetuate that fear response. Anxiety is a real fear response for the individual feeling anxious, and anxiety can be debilitating for the sufferer. Now that you know how anxiety happens in your brain, we can pay attention to how we can deliberately use our prefrontal cortex to turn off an inappropriate anxiety response once a threat is